Hey guys, today we are looking at 1.6, which is all about square and cube roots. So square and cube roots kind of not really the opposite, but can be the opposite of an exponent. They kind of do undo each other at times, depending on what kind of root we're talking about and what kind of exponent we're talking about. But we'll focus on that later. When we start using these to undo each other, then we can do that. But for right now, let's just talk about what square roots are, how they behave, and how we handle them. So before we can talk about square roots, we need to talk about what a perfect square is. So if we have the square, which like we talked about yesterday in 1.5, square is just the specific name we use for raising something to the second power, right? The exponent of 2 is squared, just like exponent of 3 is cubed. We talked about that the other day. So the square of an integer squared, is called a perfect square. So the first 10 perfect squares are good for us to know. We should already know these. They're on our times table. And actually you guys have on your times table, that multiplication table, all the way up to 20 by 20. So you have all the way up to 20 squared. These perfect squares on your multiplication table, they're that diagonal to go down through the center of my table, because that's 1 times 1, 1 squared is 1, 2 times 2, which is 2 squared is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 49, 81, 64, 81, and 100. So that's my first 10 integers, my first 10 digits squared, right? Just multiplied by themselves. So that bottom row there that we just wrote in there, that's the list of the first 10 perfect squares, meaning there's a whole number that can multiply itself and give me that solution. So square roots, they're the opposite of squaring a number. They're kind of, like I said earlier, they kind of work backwards. They undo something that's been squared. So the opposite of squaring a number is finding the square root. We're trying to figure out what number squared would give me what's underneath what we call my radical. So when we're taking a square root, any square root of a positive number, so if a positive number is underneath my square root symbol, it actually has 2 different square roots. And that's because you could square a positive number or a negative number and still end up with that solution. So for this example here, what numbers can you square to get 16? Well, we know from that list up above that 4 squared, 4 times 4 is positive 16. But we also have negative 4, and it's not as obvious to us. But we do know from earlier sections that when we multiply 2 negatives together, we end up getting a positive number. So negative 4 times negative 4, which is negative 4 squared, would also give me a positive 16. So kind of different, kind of funky, kind of weird, but that is an option for us. Now, negative numbers, they don't have any square roots. We cannot take the square root of a negative number, because like we just saw, anytime we square something, my answer is always positive. If we square a positive number, it stays positive. If we square a negative number, it becomes positive. So we're never going to have any square roots that have negative inside my absolute value, or inside my square root symbol. What number only has 1 square root? Well, that one's a little bit unique. 0 is the number that only has 1 square root, because the only thing you can multiply by itself to get 0 is 0. So 0 squared is 0, so the square root of 0 is 0. All right, getting into some of the notation side of things, the symbols that we'll use to represent square roots. We have this radical sign, not the X part of it, but just this kind of looks like almost like a, what do they call that? Not a sonogram, like the heartbeat, like when your cardiogram, when you're monitoring heartbeats, like you see it on TV and stuff, or have that little boop, boop, boop. Anyway, so we use that symbol to represent the square root of x. In this case, x can just be replaced with whatever number we want. So the square root of x, which is this first one here, this is just used to represent the positive square root of x. And then obviously if we throw a negative sign out in front, this next one down here, the negative out in front of my square root is the negative square root of x. So again, those two, the negative square root, if the negative is on the outside, that's fine, because we're going to take that square root first and then apply the negative afterwards. If we ended up with a negative underneath my square root symbol, underneath my radical, that is when there would be no solution. There's no possibility for evaluating. Okay, so let's jump into some examples. I think if we do our even or our odd problems, we'll just kind of do half of them as usual. So what we're trying to figure out, again, the square root symbol is asking me what number would I have to square in order to get what's underneath my radical. So for this first one, if we do our odds together, the square root of 49 would be positive 7, because 7 squared is 49. So the square root of 49 would have to be 7. 7 is the thing that squared, gives me 49. For number 3, we've got the square root of the negative square root of 4. So again, here, very careful, because I can take my square root of 4, which the square root of 4 is 2, right? 2 squared is 4. So my answer in this case should be negative 2, because that negative sign out in front stays with it. My square root of 4 is 2. I make it negative, so negative 2. With number 5, this is the first one that hasn't been on our list before, the negative square root of 196. So if you don't see it on your list, this one still should show up on your multiplication table, on your times table. But I will also show you how we can handle that with our calculators, because our calculators can do square roots for us quite easily. So if you're using one of my calculators, so one that looks like this, the square root symbol is to the left of the 7. So the button itself, I don't know how well you guys can see this, probably not very well, but the button itself has an x squared on it. The symbol right above it on the actual calculator, not the button, is that radical symbol. So to get that onto your screen, to get that into your input, you have to hit the second button in the top left corner. So I'm going to hit second, and then that x squared button, if you hit that, it should pop up with that square root symbol and a little parenthesis. It should look something like this if we do my square root symbol, and then opens a parenthesis right away. So if that is, or once you get that typed in, then you can just do 196. You can close the parenthesis if you want to, but you can also just hit equals. So I'm going to type in 196, hit equals, and it should give me that 14 is the square root of 196. So that's an easy way for you to check your stuff. Square root of 196 is 14. I have to be careful here because I did have that negative out in front. So really, my solution in this one should be negative 14, because that negative sign in front of my square root symbol, my radical symbol. Okay. Something with number 7, we deal with fractions. If you have a fraction that you're taking the square root of, you can split this up and just find the individual square roots of your numerator and your denominator. So this is the same thing as saying the square root of 1 over the square root of 16, and you can just do them separately. So from our list, we know that the square root of 1 is 1, because 1 squared is 1. The square root of 16, we've already seen, is positive 4, because 4 squared gives me 16. Okay. Last one here with number 9. Number 9, same idea. I've got a fraction. I can split this up into 2 separate radicals. Square root of 49 over the square root of 144. Again, you can go to your list. You can go to your multiplication table. Again, those are the nice diagonals going straight down the middle of my multiplication table, my times table. But we should be able to identify one way or the other. Or I guess you also could use your calculator if you get good at that. We should end up with 7 over 12, because 12 squared is 144, 7 squared is 49. Okay. So if we take a look at perfect versus non-perfect square roots, and here we should be able to identify either using our calculator or from our times table which ones are perfect squares and which ones are not. So if they're asking us here to circle all the perfect squares, the obvious ones that we went through, 9 is 3 squared, 1 is 1 squared, 64 was 8 squared. That was from my list up above. But we do also have 2 others in this list that are still perfect squares that weren't in my list. So you can, again, either use your times table, go through those diagonals. If there's anything that multiplies itself to give me one of these numbers, that's what we call a perfect square. Or you could test with your calculator and do your square root of 32. It's a decimal, so that doesn't work. Square root of 50 is a decimal. That doesn't work. 121, that's actually 11 squared. 11 squared is 121. And then my other one in this list, 324, I know is a perfect square, and it is 18 squared. 18 squared is 324. So those are our perfect squares. So all the ones that are not circled, those would be non-perfect square roots. Non-perfect square roots. Okay. So heading down to our next section, we could go through and estimate what those non-perfect square roots are. We could approximate what their values are. But for us in here, I'm not super concerned with this process because, again, all of us have our calculators. We can find the exact value of it if there is an application where we would need it. But if you were going through and needing to do something like this, we could approximate which 2 numbers it would have to be between for my square root values, for my squared values. So just real quick, if we take a look, number 11, if we continue with the odds, number 11, the square root of 115, on our list or through our multiplication table, we should see that 100 is a perfect square, 121 is another perfect square, and since 115 is between those 2 numbers, the value of this square root is going to be somewhere between 10 and 11, because 10 squared is 100, 11 squared is 121, so the square root of 115 has to be somewhere between those 2 values. Okay. Same thing for 13. I'm not concerned with the negative part of it right now. I'm just looking at 41. What 2 perfect squares is 41 between? Well, 36 and 49 are perfect squares, which would be 6 and 7. Right, 6 squared is 36, 7 squared is 49. So my 41 has to be somewhere between those 2. So it has to be somewhere between -6 and -7 because of that negative symbol there. Okay. I'm not going to spend a lot of time on that section. I'm just going to kind of continue on. You could approximate it to the nearest tenth. So this is where I would go ahead and start using a calculator anyway. If it's a non-perfect square root and I'm asked to evaluate it, I'm just going to use my calculator to figure out what that value is. So on 16, 17, and 18, it asks us to approximate each square root to the nearest tenth. So if we wanted to do that using a calculator, if I wanted to find the square root of 84, which we know because it's just a little bit more than 81, should be 9 point something. But if we use our calculator, it gives us 9.16515,139, yada, 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 a whole bunch of numbers. So if I wanted to approximate this to the nearest tenth, tenth being my first decimal place, my first decimal place, 9.16 should round to 9.2. 9.2 would be the closest approximation that we could figure out. But again, I'm not super concerned with that. I don't want to spend a lot of time on it because it's not something we generally will have to do very often until later in maybe pre-algebra, definitely algebra 1. We're starting to work with some square roots that might not be perfect, but for the most part, we'll be dealing with some perfect stuff. Okay, on to our last idea here. So perfect squares, we know, as we talked about just now, those are things that when you square them, when you raise them to the second power, gives us nice whole numbers. We also have this idea of a perfect cube. Now again, in 1.5, in our exponent section, we talked about how a cube is the fancy word for a power of 3. So raising it to the third power is cubing it. So the cube of an integer we can just call a perfect cube. Same idea as square roots and perfect squares. It's just some number to the third power gives us whatever this number is in my list. So 1 to the third power is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. And I'm just going to go ahead and fill in my list here with all my perfect cubes. If you wanted to evaluate that using your calculator, we worked all of last section on how we can evaluate an exponent, an exponential term with our calculator. So 6 to the third power, you'd use 6. That little rooftop button to the third power gives us 216. So I'm going to go ahead and fill this in. Once I'm done filling it in, if you want to pause the video and make sure it's all copied down, I would definitely suggest doing that. So 343, 512, 729, and 1,000. So cube roots, same idea as square roots. It's just looking at perfect cubes instead of perfect squares. The opposite of cubing a number is finding the cube root. Now a little bit different because with cube roots, because we're multiplying 3 numbers together, 3 of the same thing, all integers only have a single cube root. Because if we're multiplying 3 things together, a positive stays positive, a negative stays negative. Right? So if I'm looking at the cube, what number can be cubed to give me positive 8? Well, we saw on my list here, right, 2 cubed gives me positive 8. 2 times 2 times 2 gives me a positive. They're all positive. It stays positive. If I wanted to get negative 8 underneath my cube root symbol, the only thing that I can use to find my perfect cube that is negative will be a negative 2. Because negative 2 times negative 2 is a positive 4, times our third negative 2 would get me back to be a negative 8. So basically our rule, whatever symbol we're trying to evaluate, if it's a positive cube root, I'm going to have a positive solution. If I have a negative cube root, it's a negative solution. We again have the radical symbol in here. You can see I'm going to zoom in so it's nice and big. We still use that radical symbol like we did with square root, but now we indicate here with a little 3 that it's a cube root. I'm trying to find the third power that makes my number underneath the radical true. So that's the only difference here. So if we again go through our odd problems, we're looking for the cube root of 64. So again, very important here that we're looking at the cube root, not the square root, because 64 is one of those unique ones where it's both a perfect cube and a perfect square. Kind of strange. If I'm looking for the cube root of 64, it should be positive 4, because 4 to the third power gives me 64. Okay, two more. Number 21, cube root of a negative 27. So again, we can look at our list for what perfect cube is 27, which would be 3. But in this case, because I'm trying to find the cube root of a negative, it should be a negative 3. With our last one, with number 23, this is definitely not on our list. It's a really big number, negative 2,197. So with this, it's a little more complicated to write in or type it in onto our calculator, but it still can do this. It definitely still does cube roots. So if we're doing this, I'm going to write out my full list of symbols and I'll kind of walk you through it on the calculator. Because for this, the button above my x squared button, so that exponent button that we used, that little rooftop button, if you look at the thing that's written on the calculator right above that, it looks like this. It's a little x and then the radical symbol. That button lets you choose what root we're trying to evaluate. So the one that's attached to your x squared button that we used for perfect squares, or for square roots, that's just a power of 2. This button allows you to pick any root that you want. So since we want to do cube roots, we were looking for a third power. The way that we have to type this in, we're going to have 3 cube root negative 2197. That's what's going to look like on our screen. So to actually do that on our calculator, we're going to hit the 3 button first. So we have a 3 on our screen. To get this symbol in here, to get my x root symbol, my x radical symbol, you're going to, again, do second, just like we did in the square roots, but then you're going to hit that exponent button. And again, it should fill in with a little x radical, and then you can type in your negative 2197. We should end up with, that's still a highlighter, we should still end up with negative 13. So again, I'll write out the full keystrokes here. So you'll hit your 3, you'll hit your second, this little rooftop button, because that gives you your, when you hit second and then that, it gives you your x root symbol, and then the negative 2197, and then hit equals. And it should give you negative 13. If it doesn't, talk to me, talk to Mrs. Smith. We can figure out what's going on, what's going wrong, and help you out as much as we can. That's it for 1.6 notes. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.